Okay, hi everyone, welcome. Welcome to our session entitled Arctic Maps, Models and Indicators, Exploring Tools and Resources to Collect, Visualize and Communicate Environmental Change and Responses in the Circumpolar North. So over the next hour, we'll hear from our featured panelists on the ways in which our understanding of permafrost thaw in the Arctic, permafrost thaw and Arctic climate change are meaningfully informed by observations and monitoring, not only by Arctic researchers, but also by communities living on lands affected by climate change. Our speakers will share their experience of identifying indicators of permafrost thaw and climate change, gathering information in collaboration with Indigenous knowledge holders and researchers, and how they communicate this information to a broader audience. This communication may involve data, visualization, maps, films, or other means of synthesizing, or should ultimately be used to accelerate scientific research and policy responses. After each speaker presents, we'll invite questions both from the audience and online, and we'll reserve time at the end of the presentations for additional panel questions. We're going to have the speakers come up in a moment. I'll introduce each speaker and then they'll present. So first, well, I'll introduce everyone right now. So we have Dr. Sue Natalie is a senior scientist at Woodwell Climate Research Center and the lead of the Permafrost Pathways Project, a collaborative initiative that seeks to harness the combined expertise of leading research institutions and on-the-ground organizations specializing in climate science, policy, and environmental justice to inform and develop adaptation and mitigation strategies to address permafrost thaw. We have Jackie Catalina Schaefer, who is the Director for Climate Initiatives at the Alaska Native Health Consortium, a position supported by the National Oceanic and Atmospheric Administration, and co-principal investigator on the study of environmental Arctic change, or SEARCH, project funded by the US National Science Foundation. We'll have Gustav Hugelius, who is a professor in the Department of Physical Geography, Vice Director of the Bolin Center of Climate Research, and co-lead at the Research and Unit Landscape, Environment and Geomatics at Stockholm University. Next, we'll have Kelly Moneymaker, who is a social and climate justice activist and filmmaker, who, through her Samoan genealogy and adoptive Inupiat, apologies if I've butchered that identity, her latest professional endeavors include the documentary film Drum Song, The Rhythm of Life, which will premiere at the Pavilion on December 6th. With its accompanying soundtrack and a new solo album. And finally, we'll have Claire Treat, who is a research group leader in the Permafrost Research Station at Alfred Wegener Institute, Helmholtz Center in Germany for the polar and marine research. And I'm Grant MacDonald. I'm a postdoctoral researcher at the University of Victoria studying sea ice. So we'll start now with Jackie Catalina Schaefer. And yeah, it should just go this out.
Hello, everyone. Mga taga Catalina, nalagmishka Jackie Schaefer. Inibinarunga anirunga kikikagrumi. I'm Jackie Catalina Schaefer. I'm Inupiaq. I am from Northwest Alaska, the community of Kikikagru, which is also named after the Russian explorer Otto von Kotzebue and most of the time called Kotzebue. I am here to share a little bit about the realities of permafrost melt in Alaska. I am the Director of Climate Initiatives for the Alaska Native Tribal Health Consortium, and it is our tribal health network that works with all 229 tribes across the state of Alaska. Right, so these are just, I'm not going to go read them. These, this slide represents really current rural Alaskan stats. Most of our communities are rural in the sense that they have no road systems to them, so you have to fly in. These communities were created when Western Contact came, and they only came in the summer, so Year after year in the summer months, they came with their ships, and wherever they saw people, they established a community, either by a church or a post office or a school. Very few communities received schools, so it was either a church or a post office. These communities were not communities, they were their fishing grounds where they collected their summer food. We are very seasonal people, and we live by season still today. Except instead of moving along with our food resources, we now go out and collect them and bring them back to our colonized community, which is usually placed on fragile ground. We have 144 threatened communities in the state of Alaska, which almost encompasses all communities in our state. So permafrost is just one element that we're facing when it comes to climate change impacts. We have three ways of responding to this. Our communities could choose to protect in place. They could do a managed retreat and hopscotch away from danger, or they could do a full relocation. Some communities don't get to choose. They are imminently threatened, and they have no choice but to relocate. The unfortunate reality is that we have very inequitable delivery systems for resources and services, and the money usually doesn't match the seasonal time frame in which we have access to our communities. Our communities have, again, seasonal challenges. In the Arctic, when it's freezing in the fall, you have a 4 to 6 week window where some communities are very hard to access. And then in the spring, you have the same with the thaw. Climate change impacts is shifting this time a little bit, so it makes it very difficult to fit on a Western calendar when it comes to project funding and meeting deadlines. So our communities usually have one person that wears multiple hats. They usually have multiple layers of governance, which is part of the Alaska Native Claims Settlement Act. And that act allowed us to continue our way of life on our traditional lands, but it separated the finance for-profit corporations from the tribal governance. And so we have tribal governance that governs the people, and we have land ownership that is owned by corporations. So it's a very unusual situation. We also have included in that, in most communities, a municipal arm, which is the city government. So when you work in communities, you're working through all these layers, but you're one person trying to access funding from a whole federal system. So it's very inequitable. The processes are very structured for core America, not for the Arctic. Current trends and impacts to climate change. This really does show like there are layers. I'm going to share a story of one community that has these multiple layers of climate impacts and how destructive it is because it's accelerating. And permafrost melt, as we know, is a trigger to that. As it releases methane, it accelerates that climate cycle, that negative climate cycle. The other thing that I like to mention is, I was raised on the coast and we have permafrost there. Recently, we had a lake drain right up from my community, which was my sister's freshwater source for the winter. And the lake completely drained in 8 hours. What it did show, and it exposed along the coast, was old ancient Yerama permafrost, which we didn't know we had there. So there's so much we don't know about what we're dealing with. This is a geographical map that shows the size of Alaska in comparison to the US. And some of the areas that obviously the entire state is facing climate response to climate impacts. And it's very difficult if we don't know and fully understand what we're dealing with to come up with appropriate solutions in a timely fashion. And then first we have to know, and then we have to seek the funding to match alongside that. So it's kind of a conundrum right now because we're struggling to get equitable access to resources for our tribes, but it's also that seasonal cycle that people in Washington, D.C. have access to roads and infrastructure, whereas in our communities, we do not. We have a report that is recently published called The Unmet Needs for Environmentally Threatened Alaska Native Villages. That report, does this show up very well? Okay. That report is focused on infrastructure, There are a lot of other components when you look through a public health lens that are impacted by climate. Infrastructure is just one. Climate impacts everything. It impacts everything in a community, everything in the environment, and everything when it pertains to people, animals, and birds. And so we have to understand that what we don't know, what we do know is these communities are sinking. What we don't know is what types of permafrost are underneath the ground, because we've always been a reactive response community system. And so FEMA will come in after the fact once the disaster has happened. So this is the second layer of communities that have this issue as well. So as you see, most of these communities are along the coast, and many are centered in the southwest portion of Alaska. Southwest Alaska is a Yupik culture. We have 11 distinct cultures in our state, very different. The Yupik culture, Yupik is the second most spoken language in the United States after Spanish. There's a very small population, but they all speak Yupik. This Yupik culture is very strong, and their connection to the land, air, the migratory birds, because this is swampy land on permafrost, they knew and they migrated, so they never were in the same spot for a very long time. And so now they have all these little communities, very small, most of them under 250 people in population, and they're all on fragile ground. And now we've had decades of this human impact in the stationary fashion of living, impacting that permafrost. I'm going to share just one story real quick about the story of one of these communities in that southwest region of Alaska, the community of Nuktak. Nuktak in English is Nutak. And this is a fully relocating community, not by choice, but because the land on their river is chomping away up to 80 feet a year. And on top of that, they have this permafrost melt. This community has never been served water and sanitation services. They don't have roads, they only have boardwalks. And so the impact on top of impact is very traumatic to a population that really is kind of in this space that there is no way out. And it's really important to understand that. So the YK Delta, the Yukon-Kuskokwim Delta, has this type of permafrost, degrading permafrost, accelerated rates. And on top of it, last year we had tundra fire in that same area. So we're seeing things that you wouldn't think this tundra could burn because it seems really wet. But we have these conundrums because of this negative climate cycle. And what it does is it affects all the Western infrastructure that has been placed there. It affects the energy systems, the transportation systems, the housing systems. And it's important to understand that if it affects everything. So we have to first understand what we're dealing with in order to find appropriate, solutions for this Yupik community. And I'll leave that there. So, Fianakpak.
Thank you very much. We'll invite questions at the end of everyone's presentations. So next we have Kelly. Thank you.
Hello, my name is Kelly Moneymaker. I am a native Alaskan in the way that I was born and raised there. My genealogy is Samoan, but I was raised by my dad, who's a Inupiat, and his Irish-Italian wife. I love good food, no matter where I am. Today, my journey brings me here, and I had to leave home to find a different type of voice because I have always been a singer and a performer. But I was in New Zealand and was caught without a visa, and I found the fastest way to get one would be to go back to university. I had the honor of working with the Tokelauan people in 2019 on a documentary called Vaka, which was about their combined use of cultural knowledge combined with modern technology in response to climate crisis. I was so inspired by their resourcefulness and their ancestral wisdom that it really moved me. And I started to realize as I was doing the research, how much our stories were similar to the people at home. So I said to my husband, you know, my master's degree, I'm going to go and do a project in Alaska. And he said, that's a wonderful idea. And then COVID hit. So I had to problem solve and how can I tell this story? How can I elevate other Native voices and from a distance? And so I had this great idea. Hire a local crew to tell the story. How better to elevate the voices than to hire the people who are there on the ice, on the land. And so I was very fortunate. I started doing research and watching all kinds of videos, CNN, Nat Geo, you name it. I was in there. And Dennis Davis came up. He's known as the Eskimo Fixer. And he had drone footage. And it was spectacular. I said, there he is. There's my drone flyer right there. He also happens to be an amazing production coordinator. He knows everyone across the state of Alaska. Then I was like, who's going to be my DP? So I was watching Deadliest Catch, which is very popular in New Zealand. And Tom Trainer came up. He's an Emmy-nominated director of photography and field producer. And I basically stalked these two men until they said yes. They would be my team. While we were filming, and I was directing over the phone while they're out on the ice, it was very limited communication, but we made it work. And then while we were doing that in Shishmaref, I needed to shoot WEO, the World Eskimo Indian Olympics. And so I called the University of Alaska Fairbanks, and they gave me Gabriel Derrick, who is a phenomenal cinematographer, color gradist, and editor. So he came on board to work with us as well. These are shots of us filming at 7 Mile Ice Pond on a muskox hunt just outside of Shishmaref, Alaska, on the northwest coast. And so I finally was able to make it there. This was the second round of filming. And I rode in the sled with all the equipment. And I have to say that I reported back to the villagers that they needed to create a sealskin bra. As you can see, there are a lot of climate challenges there. Even though we're facing the climate crisis, the weather is very unpredictable. So some days it snows a lot, some days the ice is very thin. And so Dennis has been using his drone, which he uses for filmmaking, to also as a tool to keep the hunters safe as they cross the ice. He can see where there's holes and there's spots that he needs to keep his hunters away from. So this is now part of the adaptation process. And so we went with that story about Indigenous climate adaptation across Alaska because we are being severely impacted on all fronts. Since over 80% of our state has permafrost, you can imagine as the temperatures rise, how devastating this is. So if you're a coastal Alaskan, you've got permafrost melting at the coast from the warm waters, that not only is the ice melting from underneath, but then it's eroding away the shorelines. And then you've got permafrost collapse, as Jackie talked about, water's disappearing because permafrost holds water in place. So these are some of the things that my team has been out there filming so that we can actively elevate the local Native voices. This is a different day, 20 below zero for both of these expeditions on the ice. And we're trying to film and the gear is freezing up. We're warming it by sticking it in our jackets against our skin to keep it warm. And we were ice fishing with the community, some Shishmaref villagers. We had a very productive day and we had quite the smelt feast when we got back from that shoot. Delicious. So through this process, I started to think, well, how can we indigenize this further? I really want the voices to be heard on all levels, all layers. And so we had the crew, and the crew was mostly Indigenous or Indigenous adjacent, I like to say, because Tom, although he is not Native, he was raised by his Anupiat stepdad, who is Boyack. He runs Ryan Air Cargo for Alaskans and helped facilitate all the movement across the ice by shipping our gear for us. So I reached out to International Arctic Research Center, and they introduced me to Margaret Rudolph, who's a postdoctorate researcher for the for IARC, and she specializes in boundary spanning. And so she has a master's in engineering, and she is a permafrost expert. And she was working for the oil companies, and she realized, I really want to indigenize how things are done. And so she represents her communities, and she's able to communicate on both ends. And therefore, I feel there's a stronger representation with the oil companies, with any sort of development going on. And this is her in the permafrost tunnel in Fairbanks. So we got to go in there and see all the different types of ice. She's showing us microlenticular ice lenses in this particular bit of ice, and how it's mixed with the silt. And when that ice melts, it's just silt and mud, and therefore it collapses. And that's why our infrastructure is disappearing at a rapid rate. This is Roberta Turok Glenn Broad. She is the project coordinator and the community liaison for Alaska Arctic Observatory and Knowledge Hub. And so this is the observers on the ice, and they're taking measurements of all the coastal ice and the disappearance of the coastlines. And so she's collecting that data with 5 Bristol Bay local communities. And I was seeing the map as it recedes, and it's already receded so much. In an overnight storm event, they can lose up to 200 feet of land. So this is an example of that permafrost erosion that Jackie was talking about, how the waters are warming. And as they warm and they touch that coastline, it starts to melt the permafrost at the edges. And then when a big storm event happens, it just comes in and just grabs it and takes it out to sea. So as we're going through this process, and I'm still in New Zealand for a lot of this, I said, how can we not only indigenize this further, but also get youth involved? And so we reached out to the communities and we asked the villagers, how can we have a representative come in from the community, a youth who's interested in media or science or engineering, have them be part of this process. And they can ask the questions that I've submitted to the village council and the elders, and they've approved them, but they can also ask their own questions. And I found that through this process, not only did I learn the most, but we had the best experiences with our interviewees. They were more comfortable because it was someone from their own community. So it was like having a cup of coffee or a tea with someone and just telling stories and having conversations. Or, Native peoples can be very shy. And if someone would freeze up, that younger boundary spanner, or local host, as we call them, would remind them, remember when you were being chased by the polar bear on the ice? Or remember when, so-and-so fell through the ice, and that's happening more frequently. So this was a very important part of the engagement process, and it is something that we're hoping to facilitate further in the future and get more youth involved and give them camera experiences and audio experiences so that they can walk away and be their own voice, have all the tools to tell their own stories out there on the ice. And these are some of our local interviewees being interviewed by a young local host who's now become a teacher in the community. He was able to get them to laugh because they were very shy. And this is one of our elders. Clifford was a former reindeer herder, and he is highly respected in his community. He has so much knowledge. And he also has a wicked sense of humor. So in the film, you'll see his personality come through. He's the heart, I think, of this film. And he said to us, which brought me to tears in a way, he said, I have been interviewed hundreds of times for climate change, but this is the first time I've enjoyed myself. And that meant a lot to me because that meant he was comfortable, and we got a lot of information out of him. So we learned a lot through this process. And so we're hoping to pass these processes off to the youth so that they can feel empowered with their own voices and all the tools. And this one is very inquisitive. Keenan, he was out there on the fishing with us. So while I was at university and I went on to do my master's, I really focused on indigenizing a methodology for creative media production. Because with climate crisis, there are so many crews going in and out of Alaska that there's engagement fatigue amongst the villagers, and a lot of villagers are just slamming down the phone. They don't want to have anything to do with media. So it's a challenge to someone like me and my crew who want to uplift those voices, but they don't want to have any part of it because of the way they've already been treated. So we're trying to change their minds as we do this. And so while I was at university too, I was struggling because I was trying to tell my thesis in an Indigenous manner. And I was told that circular storytelling doesn't work. And I said, well, how does it not work if it's been around for over 10,000 years? This is how our knowledge is passed on, whether you're Samoan or you're Maori or you're Tokelauan or you're Inupiat. We hand down our knowledge through storytelling and through dances and songs. And so I think there's a lot of strength in that knowledge, because you start telling a story and you take this journey and you come around and you touch base on that same topic and you wind the next layer around, but you're always starting and then stopping. But when you reach the end, it's actually the beginning. And so you come around and you wind all of that history, and those touch points create a spine of strength. We have strength in our Indigenous knowledge. You don't know where you're going until you know where you've been. And so film is just digital storytelling, but we're trying to indigenize it. So thank you for making space for us at this. We have the trailer for the film if you'd like to see it.
Brilliant. Thank you very much, Kelly.
I did forget to mention, the is on the 6th at 2:30 in the main prize fair space.
Which is in the nature building. What is the name of the building? Yeah.
Yeah.
Number 87.
Excuse me?
Building number 87.
Building number 87. I feel like there's nothing more for me to say. I'm happy to maybe fill in a little bit of space, but I think everyone here has heard enough from these two amazing women. I guess I'm coming from this from a really different perspective, right? I'm a Western scientist from outside of the Arctic, from the lower 48. And my training is, I have this standard, academic PhD, and what do I have to bring to this? And honestly, I don't know. I will say one thing that I know, what's been very beneficial and really critical for me as a researcher studying climate change in the Arctic is Indigenous knowledge holders and my colleagues as helping me to understand this system. Because when we think about climate change, it's so complex. And what happens when we go in to get our PhD is we get put into this very, very, very narrow area where we get this, extreme expertise in one things, and that's just not how the world works. And so I lead a program called Permafrost Pathways. As part of that program, we have 10 tribes in Alaska who are partners on this, and they are really, really critical for driving the work that I do. And I come into this as a partner with them, but really they are the lead. And it's very challenging as a scientist in the system as we have it set up, because this is not an indigenized space. This is a space that has been very much guided and continues to be guided by past colonial practices and continuing colonial practices. And so with that said, this is the area, kind of what drives the work that I do is this thawing of permafrost, an extreme thawing of this permafrost as permafrost scientist, but this is not happening in a bubble. And I'm going to just share a story from one of the communities that I work with, and I know I'm going to just butcher the name, Wegener. You want to correct me or?
Yeah, it's you good.
Yeah, I figure the Alaskans would know better. So I'm just Jackie went through a lot of the sort of interacting processes and changes that are happening, but you can see a lot of that in this picture of this community. And so they're a coastal community, so they're being impacted by sea level rise. You can see a number of lakes here that have drained recently as a result of permafrost thaw. They're a riverine community. You can see up here, and the river's kind of eroding and moving them away. And they have this situation where you're having lake drainage, so they're drying, but they're also getting wetter. They're having an increase in non-storm flooding events that are happening a lot. And so when I go into the community, it's like, yes, I'm a permafrost person, but the first thing I do is I go and I listen, and it's like, what's happening and what is there for me to do? What can my team do? And one of the things that we've heard from the communities and from our partners in Quig is just what's been happening. They are well aware of it, and they are the amazing communicators. But as they go, say, to federal agencies and opportunities for opening up funding, often what they need is rates of change in the format of a graph or a map. Whether that's necessary or not, it is what it is, and it is where we are now, and that's what we can provide, sort of this combination of Indigenous observations and how do we put that into something like a map. So this is an example of some of the work that we did. And so when we went into Quig, our partner, Gary Avon, showed us this map that was in a recent assessment report. And this map was developed using all of the latest science. And so they used LiDAR data and digital, high resolution digital elevation to know how high the community was. Tidal data went into this. But when Gary showed us this, him and others in the community essentially laughed when they saw this. And they laughed not because it was funny, but because it was just so off. And so the blue areas here are showing the high peak flooding, high tide flooding in this community. But the reality is this is what it looks like. It's essentially the entire community gets flooded. And what Gary described to me was islands, not islands of flooded area, but islands of unflooded area. And so we said, okay, how can we make a better map? And so Gary, drew out on a map where the areas were that were the unflooded islands. And then we went out and GPS where all these points were. And so we spent some time with him in the community going around to all these spaces. And this is what we wound up with. And this is actually what it actually does look like in the community, and shared this with a lot of folks in the community. And it's really compelling, right? And I think having this coupled with narratives and photos and stories from the community is how we kind of bring Indigenous knowledge and these
technical skills that my team has to bring this together. And I think a big message, which seems quite obvious, is that when we're working with people in the communities, it's from the start, what are the needs, what are the interests, what can we do, what can you bring to this? And then we come out with a product. Is this right? Right? And that's the phase where I think often doesn't happen things. And I know people get busy and we have, funding cycles, but spending that time to say, is this right? And because of cycles where people are out in subsistence and busy with lives, you can't always get a response in the time frame that we have expected to set up some external deadlines that don't really make sense for people's lives. And so I'm just going to stop with that short story and sort of maybe we can have more conversations about how we can sort of increase. I love this boundary spanning. And I don't know if Margaret Rudolph brought this into it, but how we can work with boundary spanners so that we can get these stories out and we can be making decisions that are just and equitable and fair at moving forward. So thanks.
Thank you very much, Sue. Next up, we have Claire. No, sorry, you can go.
We changed the order, so it's not so easy to know.
Yes, so my name is Gustav, and I'll be sort of be shifting scale a little bit and talking about the really broad scale stuff. So some ideas or just some thoughts about mapping of broad scale permafrost extent and thaw and the carbon stock in the permafrost, which leads it to be a significant climate threat. And I just take two quite recent maps as examples and just talk a little bit around the challenges we have in making those maps. This first thing that you're seeing here, this is intuitively where you see that the yellow colors are warmer, the blue are colder. But this is what this shows is actually the modeled temperature at 2 meter depth for each year relative to the mean over 2000 to 2009. So it's the last decade, the average over 2000 to 2009, and then we have how has it changed since then. And this is from I'll run it again. This is from a European Space Agency funded research project. The modeling is led by Sebastian Westermann at University of Oslo, and at least in my opinion, this is really the state. This is the state of the art permafrost model that that we have right now. One of the really better ones, and the coloring is quite alarming. So we see that even in just a little more than a decade, there's a lot of warming going on, especially in the northern permafrost zones, both in North America, but particularly in Eurasia. So this yellow color doesn't mean that all of this permafrost is thawed. It just means that it's warming really rapidly and that it will be thaw, and that the accelerated warming will soon lead to thaw and the whole permafrost boundary will move up. In some cases, you do see some regional cooling, which is probably associated not to an actual cooling over time, but just that over these decades, you've had some shifts that have led this region in Western Canada, for instance, to not actually warm as fast as the others. And that might be associated, for instance, to changes or interannual changes in snow. So if you happen to have years with very little snowfall, that actually cools the permafrost down quite a lot because the cold air can penetrate into the ground. So this doesn't mean that those regions are really cooling in total, but they're just cooling relative to that earlier decade. So this is a really important. This map is being updated. We haven't actually published the last versions of it, but it's getting better and better. And then I just want to show another map that is actually from the Arctic Permafrost Atlas. This map is from the same atlas as the art you see on the walls here, which is an atlas we're talking about it in the next session at 4 o'clock. So this is just the latest map that combines the estimated carbon stock on land in green with the estimated carbon stock in the subsea permafrost underneath the oceans. So there's a recent paper that estimated how much carbon is actually also frozen in permafrost below the ocean. But then we also have constant improvements in our assessment of on land permafrost. But actually, one of the things I wanted to talk about was that the main challenges we still have in assessing both the permafrost temperature and the carbon stock and its vulnerability is actually still that we're so limited, we're so data limited. So some really important characteristics of this permafrost region is that, first of all, it's a massive area. It's 15 million square kilometers. It's 3 times of the EU. Completely massive, right? It's a very large area. And as we've heard from all of the other speakers, it's a very complex system with immense variability. You can be standing on one piece of permafrost here, and you have 4 meters of pure peat under your feet. You step 1 meter to the side, and there's no peat at all. It's just pure ice, right? And then in 1 second you're standing on 200 kilograms of carbon, and in the next you're standing on 0 kilograms of carbon. And then we're supposed to map that across 15 million square kilometers with very, very little data. We have about 2,000 observations of soil properties in the permafrost region. Just in the EU, there's, I don't know, several 100,000, almost 500,000 of points. But in the whole Arctic, we have 2,000 or 3,000 points. So it's very challenging. And the soil properties is actually one of the key things that gives you. So changes in soil properties also dictates how quickly the permafrost will warm, how it will thaw, how much carbon is in it. This is an example from, you see 3 different types of soils. They're quite close to each other. This is from Kiktaruk Island or Herschel Island in northwestern Canada. And it's just an example of where we do really high resolution mapping of the soils. You see the soil horizons that we classify. I'm a soil scientist from the beginning. We classify these different numbers, show different types of horizons. And the colors show you the carbon density in that soil. So it's like there's immense variability even at the centimeter and decimeter scale, which is obviously challenging when we're scaling up. And this one last example of how, because we're trying to study something that's below ground, obviously we use satellites, we use drones, we use aerial photographs, but we can only see the surface expression of whatever it is that we're trying to map. And in this case, this is an aerial photograph taken out of the side of a helicopter. So it's just an oblique photo out of a helicopter window. And these areas that are in the forefront here, and these areas that are back here, we do in this photograph, we do see that they're different, but from a satellite image, we can't really tell them apart because on the surface, they have exactly the same vegetation. It's, reindeer lichen and, low shrubs. But on the left-hand side, you see these areas in the forefront, which are permafrost peat deposits with massive amounts of carbon and pure ice. And in the background, you see older river deposits from this Rogovaya River, as it's called, running in the background, that is just sand. And obviously, this difference in the soil is immensely important for the permafrost, for the carbon stock, for the feedback, for the vulnerability, all of it. But then we need to be able to map that without actually, without being able to see, without seeing it properly in the satellites. And I think we are bridging those challenges with more and more use of machine learning techniques, more and more use of getting more data and so on. But it's just an example of how we do still need so much more observations from this region, and where we also need help and input from all of the people that live there and know so much more about it. And if we could just gather all of that knowledge together, I think we would be getting much further than we currently are. So, thank you.
Now, yeah, we have that.
Okay, so I'm going to tell you about a project from some of my colleagues at the Alfred Wegener Institute that they have in collaboration with some other German colleagues. And it's called Undercover Ice Agenten, which is German for undercover ice agents, so secret agents. And this is a citizen science project tackling permafrost and permafrost thaw. So the motivation here is to look at permafrost and permafrost polygons because these are one of the most visible features in permafrost landscapes. And so the question is, can non-experts be used and trained to detect permafrost thaw in this polygonal landscape? And then, what does that say about permafrost status? In order to do this, they have a really cool program. So this is citizen science with school kids and drones. So there's 2 partner schools, one based in Aklavik in the Northwest Territories in northwestern Canada, and another school in Germany and in Berlin. And so they've paired these up as matching classrooms to try to develop a relationship between these two different school groups. So they write a bit online, and the idea of the project is that the students at the Muskar School in Klavik fly drones around their town and develop regions that they're interested in. So maybe they want to look at the berry patch or the landing or the riverbank or whatever, and they go on the class trip, first supervised with the obby scientists who teach them how to use the drones, and then they fly it wherever they want. So that's, I think the bottom images are showing some of the ones that they captured, some of the drone images that they captured. So meanwhile, in the background, there's some computer stuff going on, and these images get sent to the partner school in Germany, who are also learning about permafrost. And they are trying to map the permafrost on their iPads with a special software solution developed by some of the partners on this project. So far, in terms of the permafrost mapping, there's somewhat promising results. So they they have a lot of people testing this to try to crowdsource where they see polygons in order that they can develop machine learning algorithms and really test the extent of permafrost and permafrost extent. So these are some of the areas that they've tested and shown that the students were able to detect areas where there's permafrost with good agreement and not. And I think the take-home message was that this is this is a kind of cool, fun project because kids get to learn about permafrost, they get to fly drones and really see their landscape from a different perspective. And it incorporates concerns of the people in the school and the school district, and fosters a connection between these two regions. And with that, actually, if you are interested in learning more about this, there's a QR code and sorry, I took away the QR code. There's a QR code and a website. So undercover isogen. Thanks.
Well, thank you very much to all the speakers. We've actually run out of time for questions, but I'm sure the discussion will continue in the room and beyond. So a last round of applause, please, for all the speakers today. Thank you.